Okay, so I'm going to briefly talk about how to calculate the formula of the hydrates in this video. In the lab, we were recording the mass of the following. I'm going to actually type this one for convenience sake. We had initially the mass of the crucible and the cover. Let's change the color really quick. And so here's the mass of the crucible and cover. And hypothetically speaking, let's say it was about 25 grams. Then we measured out the mass of the hydrated MgSO4, which has a formula of MgSO4 with some amounts of water molecule attached to it. And we say that we measured about 3 grams of it. Now, all of this is occurring before heating. After we have obtained 25 grams mass of crucible cover, in addition to 3 grams of hydrated magnesium sulfate, we then heated it. So I'm going to go ahead and write before heating. And this is my after heating measurements. After heating. After heating, we obtain a mass of the crucible cover and dry MgSO4. And that was approximately, let's say hypothetically speaking, 26 grams. Now, I need to figure out the following. I need to figure out the mass of the water that was in the original hydrated magnesium sulfate compound, and I need to know the mass of the MgSO4, and this is going to be the dry compound. In order to figure out the mass of the water, all I need to do is simply take the mass of the crucible cover and dry MgSO4 and subtract it from the sum of these guys. Because if I add the mass of the crucible and the cover with the MgSO4 with a certain amount of water attached to it, I would get the entire mass of the reactants, including the crucible and cover. So here I have 25 grams plus 3 grams. That equals to 28 grams. After I heated this guy, I find out that the mass of the same thing without the water is 26 grams. So we have to figure out the mass of the water that evaporated. I would take 28 and subtract 26 from it, because that's going to be the mass of the crucible, cover, and dry MgSO4. So I get that there are total 2 grams of water that was in the 3 grams of MgSO4 that I got. Now, if I want to know how much MgSO4 weighted in the beginning initial 3 grams, I would simply subtract initial weight of the hydrated MgSO4's weight with the water's weight, in which case I have 1 gram of MgSO4. Now, if that's the case, I can go ahead and convert these guys to moles each. And I'm going to actually let you guys do that, because this is something that we just did. So by doing the unit conversion, I can get moles of water and moles of MgSO4. To figure out the ratio of MgSO4 and water in a mole of MgSO4 water compound, I need to simply divide the number of moles of water by the moles of MgSO4. This should give you a approximate whole number. If it's about 3.5, round it up to 4. If it's about rounded up to 4. If it's about 4.9, then obviously it's going to be rounded up to 5. Now, this is how you conduct the calculation to figure out the ratio of 1 mole of MgSO4 per the moles of water. The correct answer should be that for every 1 mole of MgSO4, you have 7 water molecules surrounding that. So if I were to draw this diagram, I would have MgSO4 here, and I would have 7, 1, 2, 3, 4, 5, 6, 7 water molecule attached to the main MgSO4. And the goal for us was to figure out the ratio of number of MgSO4 versus the ratio of the water. And this is how you would conduct the calculation for this particular lab. Hope this was helpful, and I will see you tomorrow.